Alright guys, first thing, we have our assignments out and our theorem sheets. Shut that door, please. Okay, everybody got their theorem sheets out? Okay, one thing that we talked about yesterday that I don't think everybody quite understood. Okay, when I have these, okay, what kind of a statement is this if it says if and only if? It's a biconditional statement, right? Okay, what does that mean? It can be flipped, meaning the original is true and so is the converse, right? Okay, so that means that if a quadrilateral is a rhombus, then it has four congruent sides. Or, if a quadrilateral has four congruent sides, then it is a rhombus. Okay, we have to understand that either way works. So really, this is two theorems in one, right? It's the original and it's the converse. You guys get what I'm saying there? Okay, so just be aware of that. Okay, it is the original and it is the converse. So, that means when I come down here, diagonals perpendicular. Okay? A parallelogram is a rhombus if and only if its diagonals are perpendicular. Okay, so what that tells us is that if it's a rhombus, then diagonals are perpendicular, right? And most of us can figure that out. Okay, most of us understand that. The part that we don't understand is that if they give me a diagram that looks like this originally, they show me diagonals are perpendicular, then what can I say about it? It's a rhombus. Okay, and that's where some of us went wrong on our proof. They showed you that these diagonals were perpendicular to each other. You should have told me it was a rhombus then. Because if it's a rhombus, then diagonals are perpendicular. Also, since it's biconditional, if diagonals are perpendicular, then it's a rhombus. Okay, so your proof, your second step on that proof should have been diagonals perpendicular, stating that it was a rhombus. Your third step, then, would say diagonals bisect angles, because once I know it's a rhombus, then I know that each diagonal bisects a pair of opposite angles, meaning that that angle must be congruent to that angle, correct? Okay. Be careful here, though, because if you had a diagram that just showed these markings, you would also be able to say that this is a what? Rhombus. Because this is an if and only if statement, biconditional. If it's a rhombus, then the diagonals bisect opposite angles. Or, if diagonals bisect opposite angles, then it's a rhombus. Okay, so we just have to be aware that those if and only if biconditional statements give you an original and a converse all in one theorem. Okay? William, what was your question?
No, I understand it now.
That help?
Yeah.
Okay. Any others? Questions on that assignment? Okay, if there's no questions, go ahead and get those handed in. And then let's get our stuff ready for 6.4, 6.5 notes. Thanks, Marty. Get it this time? All right. Thank you. We'll see you later. We gave him the choice. If he wanted to. Good. That'll be fun. That'll be good for us. I think he's only going to get 2 quarters. But yeah, it'll be good, I think. It'll be good. Just get him going. Beat up on some people. See you, buddy. Okay, you're going to need your theorem sheets out. Today, the section is about trapezoids and kites. We are only going to do trapezoids today. We are only doing trapezoids. Ready? Okay. A trapezoid, a lot of us, we know what a trapezoid looks like, right? A lot of us have a little bit of a misconception about exactly what it is, though. Specifically, a trapezoid is a quadrilateral with exactly one pair of parallel sides. So it can't have two pairs, has to have exactly one pair. So is a trapezoid a parallelogram? No, it is not. So be aware of that. A trapezoid is not a parallelogram. Okay, now most of us think of a trapezoid looking like that, right? Yeah. And that is, as long as those are parallel. Okay, that is a trapezoid. Okay? But you have to remember that's not what they have to look like. This is also a trapezoid. And that's where our misconception comes in a little bit. That doesn't, in our minds, that doesn't always register as a trapezoid. Okay? But it is. Because it has exactly one pair of parallel sides, correct? Okay. So that means it must be a trapezoid. Okay. Now, on a trapezoid, there's a few other things we know. The two sides that are parallel to each other are called bases. So that's a base, and that's a base. And these two sides are legs. How many base angles are there? There's actually 4 in this case, isn't there? Okay, because that's a base angle, right? And so is that. But so is that and that. Because they connect bases, right? Okay. So those would all 4 be base angles. Now, the type of trapezoid that we typically think of is an isosceles trapezoid. This is typically what we think of when we think of a trapezoid. Okay? It's a trapezoid with legs, or let's say congruent legs. It's a trapezoid with congruent legs. So it looks something like this. just for a second. Copy this trapezoid. Use that in a little bit. Okay. That would be an isosceles trapezoid, which again, that's typically what we think of when I hear trapezoid, right? Okay. So you typically think of an isosceles trapezoid. Just remember, they don't always have to be isosceles. Okay. Now we need our theorem sheets. Okay. On your theorem sheets, we're going to make, just like we have been with like rectangles and rhombuses. Okay. We're going to make a category here of 4 theorems that are all about trapezoids. So if you want to wait and do this at the end and put the brackets around it at the end, that's fine. Just be aware that we're going to make a category. Yeah. Okay. Nice giraffe. Nice giraffe. What's that? Okay. All right. Our first 3 theorems. Okay, again, these start under our trapezoid section. The first one we're going to call base angles congruent. And pretty easily you're going to be able to tell what this theorem is going to say, correct? Hello, Olivia.
Hello.
You want to say hi to the camera?
No.
Okay.
Not really. Are we done for one?
Yes. It's on plan book already.
What?
It's on plan book already.
Is that going to be YouTube?
Not for algebra 2, no. This is geometry. It's an add-on assignment. It's a review, right? Yeah, correct.
I walk all the way over here.
I know. It's a good thing exercise is healthy, huh?
I'm about to be.
See you later. Okay. Base angle is congruent. So what's going to happen here? Your base angles are going to be congruent. Okay, so if a trapezoid is isosceles, then both pairs of base angles are congruent. Carson, give me one pair of base angles here. Let's just say DNA, yeah. Thanks. Those, right? McKenna, the second pair? B and C. Questions on that one? That one's not too bad, right? None of the stuff that we've done this week has been too difficult, right? It's just a lot of theorems. Okay, we've done a lot of theorems this week. Okay, more than what we're used to. Okay, just remember that I'd say 90% of the problems you do have a theorem about them. Okay, so if you don't know what to do on a problem, you should probably look at your theorem sheet. A lot of you come to get help from me and you don't even have your theorem sheet with you. Okay, you should be using that on your homework when you're working on your homework. The next one is called base angles congruent converse. Basically just going to say the opposite, right? If a trapezoid has a pair, not red, blue. If a trapezoid has a pair of base angles congruent, then it is isosceles. Notice it says a pair, right? Okay, so do both pairs have to be congruent to be isosceles? No, and I'll explain that here in a second as to why that's the case. Now, so that would mean like that angle is congruent to that angle, right? And then it has to be isosceles. Okay, now the reason why both pairs don't have to be is because since these lines are parallel, what do you know about this angle and this angle? They add to 180 because they're what? Those are consecutive interior angles, back from I think chapter 3. Okay, so that's 3 chapters ago, but those are consecutive interior angles, which I know are supplementary. Okay, so that means, let's say this one's 50. Let's go a little bit higher. Let's go 80. Then that must be what? 100. Well, if that's 80, then that has to be 80, which makes this 100. So aren't they congruent anyways? Okay, that's why you only have to have one pair, because you could always prove the other pair using your parallel lines anyways. That make sense? So that's why they put that as a converse and not a biconditional statement, because it's a little bit different. Okay, questions on that one? Okay, we got one more before an example. We've got 2 theorems left. Okay, this theorem is called diagonals congruent. Now, do we already have a theorem called diagonals congruent? Yes. Yes, but that is under which category? Rectangles. Okay, this one is going under trapezoids. Okay, this tells us that if a trapezoid is isosceles, or excuse me, a trapezoid is isosceles, if and only if its diagonals are congruent. A trapezoid is isosceles if and only if its diagonals are congruent. Now, in this trapezoid, do I have diagonals right now? No. Page, where would one diagonal be at?
Yes.
That's just a side, right?
Oh, I don't know numbers.
B to D. Okay, there would be one diagonal, and Lainey, the other one would be C to A. Okay, so there's my two diagonals. If it's isosceles, then what has to be true? So AC, yep, is congruent to BD. Good. Okay. Now, unlike a rectangle, does that mean this is congruent to this, this, and this? No. Okay, that is not the case in this, because in a trapezoid, diagonals do not bisect each other. Okay, and it's pretty obvious when you look at that diagram, right? Hopefully. Now, notice this theorem has something special about it. What is it? It is a biconditional statement. So that means it's the original and the converse all in one, right? So this says if a trapezoid is isosceles, then what has to be true? The diagonals are congruent. Or it says if a trapezoid has congruent diagonals, or if the diagonals are congruent in a trapezoid, then it must be isosceles. Okay, so just be aware that that one also, just like yesterday's, works both ways. Okay, it works for both the original and the converse. Any questions on this one? Okay. Do an example here quick. They give us this diagram, same one we've been using, and they tell me that this angle is 95 degrees, that this is an isosceles trapezoid with a side length of 10. We have to figure out what is CD, what does angle A equal, what does angle C equal, and what does angle D equal. Vincent, what is the first thing you see here that you can fill in?
Angle C is 95 degrees.
Okay, angle C is 95 degrees. And how did he know that? Somebody else. How does he know that angle C is 95 degrees? Travis? Base angles are congruent. Okay, in an isosceles trapezoid, base angles are congruent, correct? And that's our theorem. Okay? What else? Amaya? CD equals 10, because it's isosceles and I have tick marks, right? Okay. Now I'm stuck with A and D. What do you think, Jacob? Okay, can you explain to us, Jacob, why A is 85? Not quite. Kind of the same idea, though. There you go. That's what I'm looking for. Because these lines are parallel, so these are consecutive interior, aren't they? And I know consecutive interior angles are blank. Supplementary. Okay, so Matthias, what's angle D?
Angle D is 85 degrees.
Also 85 for a number of reasons. You could use supplementary, or you could use base angles congruent again, right? Okay, now I had a student a few classes ago tell me, well, this is 95. Those have to be the same, so I can put an x in there. And then I can say 95 plus 95 plus x equals 360. Is that true? Yeah, that's true. Might it take you a little longer? Yeah, but are you still going to come up with 85? Yes. Because this is a quadrilateral, right? Which means the interior angles add to 360. Good. Okay, so just be aware that there are multiple ways to solve some of these problems. Okay. One other thing I want to look at real quick. What if they give you coordinate points and they want to know, do those coordinate points make an isosceles trapezoid? Kind of like a problem we had the other day, right? Okay. So, what you would have to do, just like the other day, give yourself an origin, 0, 0, and just randomly plot these points. Okay, 0, 5, 7, 4, 4, 7, 5, 0. Now, do you need graph paper to do that? No. Does it matter if they're perfect? No. What you're trying to do is you're just trying to figure out what sides are opposite from each other is what you need to know. Okay? Now, I want to know, is it an isosceles trapezoid? So the first step is just to figure out if it's a trapezoid at all, right? What do you know? What's one thing you know about a trapezoid, Royal? One pair of opposite sides are parallel, correct? Well, which ones look like they're probably parallel? The top right, bottom left, right? Okay, so what would you do to figure out if they were? You'd do the slope formula. Okay, and let's go ahead and say that they were parallel. Okay, I don't know, I haven't done the slope formula, but I'm guessing they probably are. Okay, but let's say that they are. Okay, so I did the slope formula, I figured out that they are. Do I still have to do the slope formula on the other two sides?
No. Yeah, actually, no, they're not.
Right, I do, because I want to make sure that they are not parallel, right? Okay, so I have to do the slope again, and I have to show that those are not parallel to each other. Because they can't be, right? You guys agree with that? Because in a trapezoid, it has to have exactly one pair of parallel sides. So you got to do slope again and make sure those are not parallel. Okay, now I also wanted to know, is it isosceles? Which means what? The legs, right? The legs are congruent. Does that tell you anything about these? Do you have to do distance on these? No, but you better do it on the legs, right? Okay, so you're going to have to use slope and distance formula on problems like that. Okay, and if this is 6, this had better be 6. And if it's not, that's okay, right? It's just not isosceles. Is it still a trapezoid? Yeah, it's just not an isosceles trapezoid. Okay, questions on that one? Very similar to the one we did the other day with the rhombus, right? Okay. All right, we have one more topic. We have a definition and then a theorem, and then we're done. Now, why would that stay all last week? Yeah, it won't stay. What? Okay. Alright, this is a mid-segment. Now we've already we've already talked about mid-segments. Does anybody remember what a mid-segment of a triangle is? Where's it? Right, it goes from a midpoint of one side to the midpoint of the other, right? Okay, does it tell you that it has anything to do with that third side? What was there? It's half that third side also, right, in a triangle. Okay, the mid-segment of a trapezoid is very similar. Okay, in a trapezoid, not a very good trapezoid, okay, but it goes from a midpoint to a midpoint. Okay, this would be your mid-segment. Which means, what do you know about these two things? They're congruent to each other. And these two over here, congruent. Now, are those two congruent to these two? Might they be? Maybe. If it's an isosceles trapezoid, they would be. Okay, but not right now. Because it's pretty obvious that a slanted side is longer than a vertical side, right? Okay, so that would be your mid-segment. Okay, and the last theorem that you have under your trapezoid section over there is called your mid-segment theorem. Which tells us the mid-segment of a trapezoid is parallel to both bases and 1/2 their sum. And that word sum means what? Addition. We're adding them together. So very similar to mid-segment of a triangle, right? Where it's half the third side. Except now, since I have 4 sides, I have to add those 2 extra sides. And then take half of it. Okay, so I have my trapezoid. Go ahead and draw a mid-segment in. Oops. So, Seth, what is one thing that must be true about this diagram based on this theorem?
Mid-segments half the sum of the bases.
So, what that means is that EF, because EF is the mid-segment, right, is 1/2 of the sum of the bases. So one base is good, AD plus BC. Okay, that has to be true every single time. Anybody tell me the other thing we know? Royal?
EF is parallel to BC and AD.
EF is parallel to AD, which is also parallel to BC. Good. Let me put that on top just because it comes first in our theorem, technically. Any questions on that theorem? Again, our theorems this week have been pretty straightforward and easy, right? The catch is there's just a lot of them. And there's a lot of new theorems. So make sure when you're doing your stuff, you have your theorem sheet available. Okay? Reminder here for you guys. Our proof final we will be taking next Friday. That's a week from today. Okay? So we will be reviewing on Thursday, taking our proof final on Friday, reviewing on Monday, and then for this class, for third period, your final will be on Wednesday. Okay? Also remember that all of your second quarter work is due before lunch a week from today. Okay? On Friday, December 16th. Okay? Don't forget about that. Any other questions before I give you your assignment? Okay, I'm not going to do an example of this one, just so you guys have a little bit more time to work on your assignment. Questions about final and how things are going to work and set up? Okay. On page 359, we need to do 10 through 27. We are going to add on to this on Monday. We will be adding on our kites portion of this on Monday.